So in the current problem, we look at the following case. The product of two positive numbers is 400, and we need to find the two numbers which satisfy this condition such that the sum is minimum. So to start our calculation, let x and y be our two numbers. And it satisfies the condition that the product x times y is going to be 400. It is our first equation. And the second equation is about the second statement. And we need to look at the sum. So the sum is going to be x plus y, right? It is our second equation. And please look at what we want. We want to minimize this function basically. By all the things that you have learned in calculus, we have to try to finish this problem. And because now the function is a function of two variables, we cannot do anything about it. And the better way is to convert the function s into a function of single variable by using the first equation. So let's see what we can do about that. I can write y to be the same as 400 over x. So I can replace it to the second equation. So s now becomes x plus y, and y is now the same as 400 divided by x, right? And now the s is a function of x. And mathematically, by calculus, we have to try to minimize this function. And let's see how we can do that. Let's find the first derivative of s first. So it's going to be x becomes 1. And the derivative of the second term is the same as minus 400 divided by x squared. And to find all the critical number, let's set it 0. When we set it 0, we get that 1 equals 400 divided by x squared, which means x squared is the same as 400. And mathematically, it looks like x has two choices as our final answer. It's either minus 20 or 20 or both. But please note that from the beginning, we want x to be positive. So we can cross out the first choice, which means that now we have only one critical number, which is 20. And please recall from the beginning that I want both x and y to be positive. And let's check something about this point. By the first derivative test, we can choose one point in each interval, and altogether now there are two intervals. For the first interval, I can evaluate s prime at the point 10, and similarly, for the second interval, I can evaluate the s prime at the point bigger than 20, let's say 30. And you have to evaluate the 2 points based on s prime, and s prime is given in the first line, right? And let's do the calculation together. It's quite easy to see that for s prime of 10 is actually negative. For the s prime of 30, it's going to be positive. And it means that on the graph of s of x, as a function of a single variable, and it's going to be decreasing first and then increasing. It means this point is a local minimum, right? And because of the fact that we have only one critical number, which is local minimum, and there's no chance you can get any value below this value. And actually, at the same time, it is an absolute minimum also. So now it means that at the point x equals 20, we get that this function achieve the minimum value. And let's compute this point together. Let's find the y together. And please recall that y equals 400 divided by x. This is our first equation. And it means y equals 400 divided by 20, which is 20 itself. So it means that the pair of number we are searching for is actually 20, 20. And let's find the minimum value that we are looking for at this pair of points. And the sum of them, of course, is very clear. Sum of the 2 points is x plus y, which is 20 plus 20, which is 40. And this one is actually the minimum sum that we are searching for. And that's the end of this video.